between two docks. It approaches, I don't know how to say this, G Island. Its speed is 7.4 meters per second. If the ferry slows to a stop in 12.3 seconds, what is its average acceleration? If you're at all stuck, or even if you're not stuck, I want you to get in good habits. What I want you to think about is just how I have you do your homework. Start doing these problems that way, right? So I want to know what equations come to mind when you read this, right? Average acceleration hopefully prompted something like this, right? Then I want you to write down your variables that are given. So in this case, I have it's making a run between two docks. Okay, so it slows to a stop in 12.3 seconds. So I know that delta t is that 12.3 seconds. Yes. Or you could even break it down further. You could say t initial is going to be 0. Right, we can start at 0, and then we'll go 12.3 seconds. Or if you want to be confusing, you could say t equals 10 seconds in the beginning, and then 22.3 seconds. As long as the difference is 12.3 seconds. You'll get the same thing. All right. And then it's approaching, and its speed is 7.4, and it's slowing to a stop, right? So I want to figure out what is delta v, right? Because if I have delta v, I can easily figure out what this is. So I want to know what this is, but I don't know what exactly it is, but I do know that it's equal to the final minus the initial, right? So what is your initial velocity? 7.4 meters per second. Now, what is your final velocity? 0. So I have votes? It should be negative. Yes, I missed negative signs. Very good point. Yes. Should be negative. Do as I say, not as I do. Okay. All right. This one's very similar. Let's see. Let's play one of these games. So just so you can get a feel for it. So we have a race car, which is shown as a little dot, and it's moving as shown in the one-dimensional motion diagram below. Throughout the period of time shown, what are the signs of its velocity v and its acceleration a? All right. So this is a little bit confusing as a picture. Maybe, maybe not. Maybe it's perfectly clear to you. But so we're starting at that little start dot, and we're a little race car, and then it's moving towards your left. So at your first time equals 0, right? You're just sitting at start. At time equals 1 second, let's say, right? You're at that second dot, and that velocity, that size of that little velocity arrow is your speed, right? So you're going a little bit, right? Little bit of speed. You're like 1 mile an hour. And then at time equals 2 seconds, you're going 2 miles an hour, right? So the v is growing. And then a little bit while later, maybe at 3 seconds, you are going a little bit faster, right? So I want to know, is velocity positive or negative? Is acceleration positive or negative? I have some disagreement. I look like I'm split between a couple of them. Okay, I think most people are in agreement. Velocity is negative. Is that 1 or 2, or is that 3?
No, it's 4. It's a Roman numeral. Oh, I just did this.
Okay. All right, so we've decided, so I see 3s and 4s. So I think it's pretty clear. Velocity is negative, right? Velocity is pointed at negative x. So then how do you know if acceleration is positive or negative? Because you're going in the negative direction, but then you're speeding up in the negative direction. I would encourage you to think about these equations. So I know it's like, oh, I should just like be able to guess, right? But sometimes positive and negative gets weird. So I would ask you to go back to your equations on this and think about, okay, so velocity is change in position over change in time, right? So we figured out, so if you think about where it ends, so if we just look at the whole thing, it's ending up at a large negative number from a little negative number. So it's going to be big negative plus a little negative, it's going to be negative, right? So we know that delta x is negative, time is positive, right? So that happens. So then this is negative. And then when you think about acceleration average, you're going to have delta v over delta t. And this is going to be, we know that v is negative, change in time has to be positive. So then it's negative.
What happens if change in time is negative?
You can do that in quantum mechanics.
Really?
You can go backwards in time. But not in this class, time is positive.
All right.
Time is positive.